My project is from a conference presentation I gave at the Midwest Undergraduate Geography Symposium called Designing a Series of Pollinator Gardens to Enhance Bees' Resilience by Connecting Islands of Habitat. Scientists have seen a dramatic decrease of bee populations for many reasons. Human development have affected their population because of the increase in buildings and roads, which decrease wild areas, parks, and green areas. There are less flowers for them to pollinate, which affect pollinator paths. Pesticides also affect bee population because their toxins are lethal to bees when ingested. Bee populations have also been affected by global climate change because of exposure and susceptibility to disease, fewer flowering plants and places to nest, and less time for foraging. The species that I focused on was the rusty-patched bumblebee, which is listed as an endangered species under the Endangered Species Act in the U.S. Fish and Wildlife Services. This species of bee is a more effective pollinator than honeybees for most crops. Bees provide ecosystem services by pollinating plants, flowers, and crops, and they contribute to the food security and healthy functioning of ecosystems. The economic value of pollination services provided by native insects, which is mostly done by bees, is estimated at $3 billion per year in the United States. I looked at the theory of island biogeography to help me with my research question and proposed solution. Island biogeography is a study of species composition and species richness on an island. It looks at factors that affect diversity of a specific community. It also looks at the relationship among populations and species between islands of habitat, such as genetic structuring, historical patterns, and species formation. This theory shows that extreme isolation of islands reduces the connection between other islands and continents. There are two factors that determine the number of species in an ecosystem. It is a balance between immigration rate, which is the rate of species to the island from another inhabited area, and extinction rate, which is the rate of species established on an island. These rates are determined by the size of the island and its distance to the mainland. These rates will reach an equilibrium point that determines the island's average number of different species, which is the species diversity. In the picture, you can see that islands C and A have higher extinction rates because they are smaller islands. Islands D and B have lower extinction rates because they are bigger islands, so they are more diverse. And islands C and D have higher connectivity with the mainland, and their immigration rates are higher. This theory helped with how to design pollinator gardens and where they should be placed. My research question was how to create pollinator pathways that will best provide a connector between islands of bee habitat in the urban growler neighborhood. The study area that was researched is an area in St. Paul. This area is mostly paved roads and buildings with little to no green or natural spaces. Because there are little to no green spaces, it makes it a good location to implement solutions. We call this area the urban growler neighborhood. These maps show land cover classification, and the tree canopy layer is from the University of Minnesota, which shows land use. This area is a very industrial area and has high levels of impervious surfaces and buildings, which are barriers for bees to pollinate and thrive. This map is a land use layer shown previously, and I reclassified the values of each category to show the friction of distance. Higher values are harder for bees to move across. Buildings were given the highest value of 100 as they act as a barrier for bees, so they have a higher friction of distance. This is shown in dark red. Natural areas like rivers or trees were given the lowest value of 1, as bees can easily pass over these. These areas are shown in light red as they have a lower friction of distance for bees. This data of bee habitat in the Twin Cities metro is from Landbridge Ecological. The neighborhood lies between two large disconnected islands of habitat. By placing long linear pollinator gardens in the urban growler neighborhood, we can connect these two large islands of habitat by providing landscapes with a lower friction of distance for bees to travel across. This would encourage migration between the islands of habitat. Using ideas from island biogeography will increase bee abundance and diversity, which will increase the resilience of urban bees. This map was created by running the linkage pathway tools using the islands of habitat and friction of distance layer. This tool calculates a relative value of connectivity for each cell. Each cell is given a value that determines how effective that area is in providing connectivity between the core habited areas. Green areas are easier for bees to move across and facilitate movement between the core areas. Red areas are harder for bees to move and impede movement for bees between the core areas. Areas that are green are more likely to be suitable places for pollinator gardens that are shown in purple to connect islands of habitat. By creating these long linear gardens shown in purple, we'll increase connectivity between the two big islands of habitat, increasing bee movement and resilience. Some areas have started to implement these kinds of changes and have seen success. An article published in the Nature Conservancy by Jenna Rogers called Planning for a Rainy Day looked at a cemetery that had a high water bill. They realized it was from treatment costs from stormwater and associated pollutions. They had such a high treatment cost because their cemetery had a lot of paved roads and roofs, so the fee was a square footage of all their impervious surfaces. Their solution was to plant rain gardens to collect the runoff water. 60% of the water is evaporated or collected by the plants, and these plants attract more bees and other insects. This helped ecosystem services, and their bill lowered by $25,000 per year. Another article that was published in the Nature Conservancy by Jamie Gonzalez called Nature Every Day: How to Hook Kids on the Great Outdoors saw how much cities were expanding, which caused natural areas to decline. This is the result of human impact, which leads to habitat loss that affects wildlife, climate, and water runoff. The decline of wildflowers leads to a decrease in bees and butterflies, so scientists are seeing local extinction of these insects. The average large U.S. city devotes 9.3% of its land to parks, and only 65% of the population is within walking distance of parks. In this particular study, the researchers added over 30 little public spaces to help increase wildlife and saw an increase in bee population. It also attracted more people that are able to enjoy the beautiful natural area. For my research on designing a series of pollinator gardens to enhance bees' resilience by connecting islands of habitat, I used the theory of island biogeography to help figure out how to design these gardens and where they should be placed. Then I used Linkage Mapper to assess the effectiveness of the proposed gardens. The proposed areas for the pollinator gardens in the urban growler neighborhood would be effective in connecting islands of habitat and ease the difficulty of movement for urban bees, while increasing suitable habitats and opportunities for pollination. Some places have started to plant more gardens and have shown success with added benefits.